All right, fellows, let's create our first producer in Python for Kafka. We'll be implementing those three producers to produce bus data of three different bus lines and produce the data to a Kafka topic. So have fun. So first of all, make sure that both Zookeeper and Kafka are up and running. If you don't remember how to do this, just watch the last video. And afterwards, let's create a new topic for testing reasons and let's name it test bus data. Okay, so topic got created. And now we can switch to our code editor. Let me just copy the topic name here and create a new file first of all, busdata.py. And let me just copy the name of the topic here that we remember it later on. All right, next let's create our producer with Pykafka. So let's go to our browser, search for Pykafka and jump over to the documentation, which is pretty well here. So first of all, we need to install Pykafka. With pip install Pykafka, I already did it, so no need to do any further things here. Next thing is importing the Kafka client from Pykafka. Let's just copy it over to our script and here from Pykafka import Kafka client. Next thing is basically we need to specify our client, so where our Kafka broker is running. Basically, it is localhost as well. So let's copy it over and create a new variable client, Kafka client host equals to, this is where your Kafka is running. So here it's localhost 9092. All right. Next. Basically in the documentation, next thing is, or it's describing on how we can read out our topics. So let's just try it one more time. Let's print out the topics we already created on my Kafka here. So let's move to my direction and let's execute the script. And basically here you can see all the topics I created for my local Kafka broker so far. Actually, there are a few because I did some testing up front. You remember here you see there's a B up front, the topic name, which is the case because it's stored as bytes all the time. Good. So there's one more thing we can do for a topic. So we can also read out one single topic. Let's just edit the print statement here and try what it gives us. So here I stored the topic name. Let's copy it over. And let's try what our script prints out. Here you can see it's a Pykafka topic and the name is test bus data, again with a B up front, which stands for bytes. All right, let's remove the print statement and just assign the topic test bus data to our topic variable. Next thing, producer. So this is already the next thing to actually create the producer with this comment here. But let's assign it to a variable in this case. So let's create a producer variable, assign the topic get sync producer. So this means for the above specified topic, we can just specify the producer. Next would be producing a message. So with producer.produce and then a message. Let's try it. Let's first create a Kafka console consumer that we see what we are actually consuming. What we're actually producing, sorry. So let's use the Kafka console consumer, which I showed you in the last video, on our topic test bus data. Hit enter and consumer is up and running. So now we can start producing data with our script. So let's open a new command line. Let's make this a little bit smaller and move it to the side. And here we still have our command line, right? So let's run it one more time to see if it produces actual data, the test message. And okay, we got an error here. Produce accepts a byte object as message, but it got a string. So we actually tried to produce a string test message, but Pykafka Producer expects a byte. So let's encode it here and try again. So encoding did the job. On the right in the console consumer, you can see our test message. Et voila, this is our first Kafka producer with Python. Congratulations, but let's do more. So actually, let's try, or let me show you that you can really produce a bunch of messages all the time. So this is not a programming lesson. You should never use while true in your productive program, but as mentioned, this is not a lesson here for programming. Let's just do it here, and let's print out a message, hello, with a counter here. So we created a new message variable, and let's assign this to the producer then in the second step. And nearly I forgot, of course, we need to encode it again first, two bytes. And let's also print the message on the producer side. And of course, increase the count. And then let's try what it brings us. So let's have a look at our consumer on the right and restart our producer on the left. And you see on the left, it gets printed out as bytes, and on the right, on the Kafka, you see it as messages, as string messages. And it's really fast here. So let's stop it. And you can see in this few seconds, over 6,000 messages got consumed and produced on the Python side. Actually, Kafka is feasible to do much more. Python is the limit here on my local PC, and because I've only started one producer. So let's comment it out at this point. We need it later again. And then let's move it down to have some space. Let's add the comment what we did here. So we created our first Kafka producer, and let's move it down for now. Next, basically we want to create bus data. So we need coordinates for those buses, and we get them from GeoJSON in a JSON format. So for this, we need to import JSON and move to our browser again and go to geojson.io, where we can actually generate coordinates for our bus. So let's move closer to London, where we want to see our bus lines. And just use this function here on the right to draw a line of the bus. So like this, you can end this with a double click in the end. And on the right, you get a list of coordinates for your bus, or which should fake the coordinates of a bus. Just copy them to a file and save them in JSON format to your directory, like this. I already did this upfront for my 3 bus lines, so I will cancel it at this point. All right, back to our code. So as you can see, I created a folder data with 3 JSON objects from GeoJSON.io, and you can see the coordinates below, which you clicked in GeoJSON, but you see, so here, 1, 2, 3, 4, much more. But on the top, you see some further values from the JSON, and the easy way would be to just remove those stuff up front here in the JSON file itself. But let's do it programmatically because I think it's more fun. So let's move to our script again, and let's first of all read the file we just created. So input file, open the location and the file name. bus1.json. Okay, let's print out the file. And we'll see we'll successfully read the file and get some technical information about it. So let's convert it to JSON because actually it's JSON content. So let's create a new variable JSON array, JSON loads, and gives the file name here input file. Now let's print this out, JSON array, and see what it gives us. So this gives us all the coordinates, but also the stuff up front, basically the complete content of our JSON file. But actually we only want the coordinates. So how can we remove the other stuff here? Like feature collection and so on. We don't need this. Basically we can start with the feature variable here, the feature path in the file. So let's first of all create a new coordinates variable. And from the JSON array, extract something. So it's a dictionary. And like you saw up front, let's extract the features here. Here you saw the features, which we can extract from the dict. So while doing this, there's some stuff removed already, but still some unuseful stuff which we don't want to have. So like type, feature, properties, and so on. How can we access this? So for this, let's have a look at the coordinates again of the type. And actually now it's not a dict anymore, it's a list now. And from a list, we can easily access the first object with an index. So let's first of all remove basically the first bracket with accessing the first index of this list. And now you see it's a dictionary again. And let's print it out one more time. So basically all it did is removing the first bracket, this one here. But now it's a dict again and we can access it again using the keys. So now it makes sense not to access a type key, but the geometry key, because within this key we get all the coordinates. So let's do this. And again, check the type of coordinates, and it should be again a dict, not a list anymore. Now if we check the file again, we see it's still a dict. We can now access basically the coordinates key within the geometry. So type, we don't need it. We only need the coordinates values. So let's do it via the key of the dict. Coordinates. And let's check the type again. Now we have again a list. So some typecasting here. But if you print it out now, you see it's actually a list of all the coordinates which we want to have, right? So we have a list of all the coordinates. We can access them with an index. This is what we want to have. And this is now in our coordinates variable. So what we do next is actually we send the message as a string so far, as an encoded string so far, but we want to have the data a little bit structured. So we want to have a bus line for each line. We want to have a key with a bus line and some values. We want to have a timestamp for each message to really see at what time which message was generated. And we want to, of course, have the latitude and longitude within our message we are producing to Kafka. So let's try to achieve this. Basically for timestamp and for this key, we need to import two more things. So for getting a timestamp, we are importing from datetime on the datetime library, and we are importing one more library UUID for generating random IDs. So now let's construct our message with some more useful information, and not only a hello string. So let's first create a data dictionary and now define our keys. So first of all, our bus line is equal to 00001. Then next, let's specify the key, and the key should be a combination of the bus line. So 00001, so data bus line. And the second part of the key should be a unique random ID. So for this, let's generate a UUID and make it as a string. So for this, let's write a small function. Let me think about it. Let's put it here on top. And make a function out of it. All right, and we are just using one class out of the UUID library, so and return it directly. So we are returning UUID dot UUID dot UUID4, and that's it. And we're downwards in the key, transforming it, of course, to a string. All right, the next information in our message should be the timestamp. So for this, we are using a class out of the datetime library and make it as well as a string. So we're using string datetime dot UTC now, which always gives you the current time in UTC time zone, which is important for technical systems. So next, let's access the latitudes from our coordinates array. And for testing reasons, let's just access the first one. So the latitude and the longitude of the first list entry. All right, this should be the content of each message. Let's print it one time to see if it works. And it does. So here you're getting our message with the bus line with a key, which generates you a unique random key here. Actually here, I want to have a character between the bus line and the technical UUID. So like this. Like this. And let's execute it one more time. All right, so now we see the bus line, the key 00001 with the random ID, the timestamp in UTC with hours, minutes, second, millisecond, the latitude from our coordinates and the longitude from our coordinates. All right, this should be the content of each and every message we are producing to Kafka. So now let's move on and not only construct the message, but send it to Kafka. So for this, we need to move some stuff around. First, let's create a new function to generate all those and produce all those data here. So we will forward the coordinates array to this function. And let's move things a little bit around. I hope you will not get confused. So first of all, let's indent this one. And now let's create a for loop. So for each coordinate in our coordinates array, because we want to loop through this. Wait a second. Let's do it a different way. So let's do it with e equals 0, and then while e is smaller than the length of the coordinates, let's do something. So this is basically the same, but you will later see on why we need this. So for each coordinate, we will generate a new key, a new timestamp, and we will fetch a latitude and longitude for each of the coordinates. So yeah, let me replace the 0 with the coordinate. Sorry, with the I here. So it's not the coordinates. I was too quick here. It's an I, which we're using from the top. All right, so this should generate all the data for all the coordinates already. But we also want to produce it to Kafka, right? So let's first of all create a message out of it and put it into a JSON format. So you see below we created a message here with hello, and now we will construct it out of our data dictionary in a JSON format. So we will be using JSON dumps here. Next, let's print it out to see how it looks and if it's successful. So of course we need to call the function first. And then let's move back to our script and execute it. And you see it's generating all the stuff, all with a new key and a new time zone. So the key is different all the time. The time zone is different, but latitude and longitude are all the same. That's strange. Of course. I didn't increment I, sorry. So of course it always is taking the first value then. So because I is always 0, let's increment I, run it one more time, and now you see not only the keys and timestamps are different, but also latitude and longitudes have different values now. All right, so key is different, time zone is different, and latitude and longitude are different. All right, so we successfully looped through our JSON coordinates, our GeoJSON coordinates, sorry. Now let's produce it to Kafka. For this, let's use our producer we created downwards, and let's move some stuff up. Client topic, actually also the producer, yeah. Let's move it up as a global variable somewhere, yeah. All right, so client topic and producer are global variables now on top of our function. And the producer we can move then to our function. This we can delete. And let's move the producer here. Let's keep the print statement to also see what we are producing. And make sure we encode the message, of course, to not forget about this again. Now, that's it. So I think with this, we are looping through the coordinates, generating our message with some further values, and producing it to Kafka. So let's start our console consumer again. And I'm starting it with from the beginning. You will see everything which has ever been consumed to this topic from our first tests. Now it stops. And now let's run our bus data 1 PI. And that's it already. So really quick, it looped through our file and returned all the coordinates and produced them to our Kafka topics, like we can see on our consumer on the right. So let's close our script, our producer. Let's keep the consumer open. And let's do one more thing. So basically the bus stopped at the last coordinate. This is not real life. So the bus starts again from the beginning, right? So if the bus reaches the last coordinate, it either goes backwards or it's a circle, as in this case. So it starts again from the beginning. And now let's ensure to reset I if this is the case, to create a forever loop here in this case. So if I is reaching the end of the length of the coordinates, let's move I back to 0, that it again starts from the beginning, and only if not, increment I. So let's do it again. Let's have a look at our consumer, which is still up and running, and let's restart our script. And what's wrong now? I forgot an equal sign here. Okay, one more try. Consumer on the right, script on the left, and you see the data is being produced until forever. And let's stop it for now. Let's again keep the consumer up and running. Because we only have one producer now, let's create the two other producers as well for the two other bus lines. So one for bus, wrong button. Run for bus 2 JSON, one for bus 3 JSON. So first of all, bus data 2.py. Let's replace bus 2 JSON here. This can stay, this can stay, stop it can stay as it is. The bus line will change to 02. That's it, I think. All right, let's do the same thing for our third bus line, bus data 3.py and bus 3 JSON. Sorry, the rest can stay, topic can stay, bus line changed to 3. All right, now let's see what Kafka can do and how performant it is. Our consumer is here on the top right. On the top left, we will start the producer for bus data 1. And let's open two more windows for producing bus data 2 and bus data 3. So, and let's arrange it a little bit that everything fits onto one window. So, and we need one more command line. So this looks nice. Move to our directory. I'll have a typo here. Now, as mentioned here on the top left, we start bus data 1. Here we'll start bus data 2.py, and on the bottom right, we will start bus data 3.py. And on the top right, you will see the consumer. So the Kafka console consumer of our topic. So with all three producers, we will produce to the same topic, and the consumer on the top right will read out of this topic. So let's start producer 1, producer 2, producer 3, and you see all the producers producing, the consumer on the top right is consuming, and you see it's consuming for all three bus lines. Now let's stop them. And you see the 3 we stopped at last. So that's why on the bottom there are all the leftover messages from producer 3. That's why also this differentiation in the bus line makes sense here. Now, oh, so many messages. Scroll up here is 2, so which we stopped second last. And then someone producer 1, which we stopped at first. All right, that's it. We implemented 3 producers which produce data to one Kafka topic, and we verified this with reading those data with a Kafka console consumer. In the next video, we will implement the UI together with a consumer, with a Python Kafka consumer. So I hope you will switch on again, and I am happy to see you soon. Thank you for watching. Bye bye.